So today's our topic is normal distribution. Uh, Before going to the concept of the normal distribution, we should know about the different probability distribution because when different scenarios observe and each scenario has different probability, so the collection of all possible outcome in any event, so their corresponding relative frequency makes a pattern. That pattern is observed by the probability distribution. So we can say a probability distribution is describes the behavior of the random variable, any variable whose outcome is unknown. So, for example, like if we are actually dealing with any patient and we don't know what will be their outcome, but if we know the pattern of certain distributions and certain chances that what have observed in past, so we can observe we can actually estimate the probability of that distribution. We have having two examples. For example, one is that the probability of having glaucoma in 3 patients out of 10. So what is the type of variable glaucoma is that having a glaucoma, it means we will be approaching 10 patients and asking them, do you have glaucoma or not? And there is one more instance that if I want to find the probability of hemoglobin more than 11 milligram per deciliter, this variable is now hemoglobin. It is being measured in the numbers, and we want to find out any hemoglobin more than that that threshold. So this is a kind of different variable. This is a kind of categorical variable, and this is a kind of the quantitative variable. So probability distribution actually behaves differently when dealing with different kind of variable. For example, here we go. First, we have to identify what kind of variable we have. So having glaucoma, like I just said that you are observing 10 patients and asking them, do you have glaucoma or not? Our event is that a person have glaucoma, and our non-event, the complementary event is that it does not. I mean, he or she does not have the glaucoma. So this is a kind of nominal variable which we are observing, and then we will find out how many patients will have what is will be the probability of glaucoma in that scenario. In the other scenario, when we have the hemoglobin in our as our variable of interest, that is a kind of continuous variable. Continuous variable behaves differently than the categorical variable when we are measuring them, because continuous variable has a continuity of the variable while the nominal variable has this distinct quantity. Like I just say, it has the category, I mean, yes or no, but hemoglobin has range of values which will be, I mean, which can be uncountable, and it is continued also. So briefly describing that, for nominal kind of variable, we have in biostatistic one binomial distribution, and for observing the continuous variable, there are many other distribution, but our concern is with the normal probability distribution. And what is the normal probability distribution? Basically, let's imagine that we have a height between 4.5 to 7.5 feet. So, in general population, you may have observed that if we have the range between 4.5 to 7.5, so mostly people would lie between around 5 to 6 feet, and there would be very low number of patients in the higher range and in the both higher range. Then we have another variable, BMI, body mass index, which is the ratio of the weight and height, and it has a range between 16 to 37. But if we it measures the obesity basically, or the underweight people. So we know that most of the people have a body mass index between 20 to 25 kg per meter square, and there are very low number of people who have underweight people. I'm talking about a general population, and there are very low people who have more than 30 kg per meter square. Similarly, we can talk about a DPP, which is diastolic blood pressure, whose when the range lies around 80 to 90. Like if I'm saying in the range lies around 80 to 90, it means most of the people have the values at the middle point, and there are very low values at the lower point. Even the variable were different. If I am talking about height, you can imagine, let's suppose 4.5 is here and 7.5 is the extreme side, but most of the people would lie between 5 to 6 feet. Similarly, if I'm talking about the BMI, so let's say 16 is here and 37 is here. So you may imagine that most of the people will lie between 20 to let's suppose 30 BMI. And if I'm talking about diastolic blood pressure, so the 60 is at the lower end and the 1110 is at the upper end, but the higher range and the lower range of the people will have low in number. But usually the people have the blood pressure, the diastolic blood pressure, the lower one, between 80 to, let's suppose, okay, maximum make 110. So the variable were different, but we are observing same pattern. So if we say the variable values is here and the probability is at the y-axis, so this is all of this is a kind of probability distribution. So in a way, we call them normal distribution. Normal distribution may have a different kind. It has two parameters. One is mean, another one is standard deviation. The mean defines the central point, the center of location. Okay, the measure of location. Like here we go. This is you have all of them has symmetric distribution in layman language. We can say all of them have normal distribution. You can also observe all of them have the bell-shaped curve, and the center from the center point, the left side area and the right side area in all of the kind have same. This sigma standard deviation defines the strength, spread of the of the curve. For example, just an example, if I say this curve has sigma is equal to 2, it means this curve must have the sigma more than 2, which would be, let's suppose, 5. So we may say that the spread of the curve, the spread of the curve, like this is thin, this is thick, this is must take, this is thick, and this is like this. So this is normal. I mean, not much thick, not much thin. So this thickness and thinness is described by the standard deviation, and this central point of the variable. What is the variable at the center of location? It is defined by the mean mu. So normal distribution has certain characteristics. If you see this chart, you can see the mean is at the center of the valley, at the center of the curve. It must be, and the left side of the area and the right side of the area are the mirror image of the towards the mean. Like here we go. This area, like from blue to this red line and blue to this red line, will be the same probability because, like, if I say, for example, this area from blue to red covers 30% of the area. So this area to the positive side also, I mean, to the left side of to the right side of the mean is also, we will observe 30% of the probability. One of the property of the normal distribution is that its mean, median, and mode lie on same point. And it is on the center point. Why the mean is at the central? Because it takes all the values and divide by the total number of observation. Median is a central value. It is the central value. You can also see like this area and this area have the same image. It means the median is at the center point. Mode is always the peak point, because if we have the y-axis has the relative frequency or probability, so the higher the probability, the higher the relative frequency, that value will be the mode of the data. And the normal curve shape is a bell shape and is symmetric about the mean. And symmetry means the same thing which I just said, that it means the center point has the mean, and the left side area and the right side area are the mirror image of each other. And the probability of the next of the negative side and the positive side are equal, or I can say at this moment that the probability of the left side and the right side are equal because they are spreading with the same pattern. And the total, it is again the probability, and we know the sum of all the probability equals to 1. So the total area under the curve is actually measuring the probability. The curve defines the probability. So the total area under the curve is equal to 1. And one more property is that the normal probability curve does not touches to x-axis, otherwise the probability will become exactly 0, which can never be the case in statistical theory. So but we have one concern that since we are dealing with a continuous variable, so calculating the value of a probability of with that continuous variable will be cumbersome. It will be too much difficult. So what's a statistician did? They have done a favor to the the world of in the world of statistics that they have calculated the probability of the normal curve. But one thing is that they have standardized all kind of normal curve, and while standardizing, it means the mean of that curve for which the probability have been calculated has 0, and its standard deviation is equal to 1. So it means what we have to do, we have to actually make the mean 0 and make the standard deviation is equal to 1. So if we make it, so we have the probability which are calculated, and the and such kind of normal distribution which has mean 0 and the standard deviation 1, we call them standard normal distribution, and it is usually referred as z distribution. So it's and then another name of standard normal distribution is the z distribution. If we are using the z distribution, we are actually referring towards the normal distribution which is standardized with mean 0 and the standard deviation is equal to 1, and its probabilities are calculated. Like here, the mean point is at the center, and the movement to the left side and the right side, as I told you, depends on standard deviation. For example, if we add the if we add the sigma one time, and if we subtract the sigma at one time, adding the sigma at the one time, this area covered 34.1%. And if we subtract the mu one time, since I told you that this area and this area, the blue area and this blue area have the same probability, so mu to mu minus sigma has also 0.341 probability. Similarly, mu to 2 times sigma has 0.136 probability. So it will be the same as 0.136 probability from one sigma to the another sigma. So here the how we know this, the probability are calculated in this table. Although today we are not concerned with actually how to calculate the probability within a table, because it's a very basic concept. We are studying very basic concept of probability, but you can just know that if the mean is 0 and we are moving towards one time to the left side and the one time to the while right side, so this completely covers 68.26% of the area, and the probability are also calculated here. Like I use the software SPSS for calculating the probability. So the area from -1 to 1 covers the 68.2% 26% probability, and the area from -2 to +2, its probability is 0.9544, or we can say 95.44% chances. And the area between the probability between -3 to +3 is 99.72, or we can say 0.9972 probability, and this is fixed, these are calculated. So all you need to know that these are calculated. We are not concerned with how does it come in today's lecture, but what does it actually gives us the advantage? This is our main concern in this lecture. So for example, we talked about the hemoglobin at very start. Let's suppose the mean of that hemoglobin is equal to 7 and the standard deviation is 2. And suppose hemoglobin follows a normal distribution. So we can measure with the certainty about the hemoglobin values. How? For example, if the mean is 7 here and I and if we want to add, if you want to solve this equation, mu plus sigma, minus sigma, or mu plus 2 sigma, mu minus 3 plus 3 sigma, or mu minus 3 sigma. So if I add mu plus sigma, mu is 7, sigma is 2 here. So 7 plus 2 is equal to 9, and 7 minus 2 is equal to 5. So I can say, I can actually interpret in a way that there is 68.2% chances that the hemoglobin of patients lie between 5 to 9. And if I add mu plus 2 sigma, 2 is here. This is the for the I mean fixed, and sigma is also 2. So 2 times 2 is 4, and you can also see from the negative side 2 times 2 is 4. So mu plus 2 sigma, that is 7 plus 4, is equal to 11, and 7 minus 4 is equal to 3. So 3 to 11 area covers 95.4% of the probability of the area, which is 0.954 probability. So we can say the chances of patient having the hemoglobin between 3 to 11 is 95.4%. Similarly, we can also practice the same with the 3 sigma and the minus 3 sigma. So 7 plus 3 sigma. Sigma is 2 here. 3 times 2 is 6. 7 plus 6 is equal to 13, and 7 minus 6 is equal to 1. So there is, we can say, 99.7% of the chances that the hemoglobin of the patient would lie between 1 to 13 if we have the mean 7 and the standard deviation is equal to 2. And vice versa, we can also find out that what is the probability that the patient hemoglobin will lie between 5 to 9. This 5 to 9, and the probability are these ones. Either 0.682 or 0.954 or 0.997. So the probability of a patient having hemoglobin value between 5 to 9 is 0.682. And we can also say the probability of having the hemoglobin between 3 to 11 is 0.954. Or the probability of having hemoglobin between 1 to 13 is equal to 0.9972. This is being done using this chart. Similarly, if we have the variable of the height or BMI or any other continuous variable, if you know the mean, if you know the standard deviation, you can compute the probability, or you can also compute using the probability. You can also find out you can also find out the certain level of their specific values. That's all about the normal distribution, a very basic graph. So that's it.